Section 4.8 is on isosceles and equilateral triangles. So to start off with here, we have a few vocab words to talk about. And the first one is legs, and the legs are the two congruent sides of an isosceles triangle. The vertex angle is the angle formed by those legs, and the base is the side opposite of the vertex angle. So across, straight out from the vertex angle is your base. And the base angles are the two angles that have the base as a side. So off to the right-hand side there, you can see I have drawn an isosceles triangle and labeled all of those parts. Up next, we have a couple of theorems here. The first one is the isosceles triangle theorem, and it says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So if we have an isosceles triangle with those two legs marked congruent there in the picture, then those that angle B and angle C are congruent. And then our other one is the converse of isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So it's basically going backwards. If you know the sides are congruent, then the angles are congruent. If you know the angles are congruent, then the sides are congruent. So they're showing us here in this picture that angle E is congruent to angle F. And if we know that much, then we know that the segment DE and segment DF, so those two legs, are congruent. So for example 1 here, it says the distance from Earth to nearby stars can be measured using the parallax method, which requires observing the positions of a star 6 months apart. If the distance, which is LM, to a star in July is 4.0 times 10 to the 13th kilometers, explain why the distance LK to the star in January is the same. And you're going to assume the distance from Earth to the sun does not change. So this side over here is 4.0 times 10 to the 13th. And we're given that angle M here is 89.6. So we want to try to figure out this other angle right here. We do know that that outside angle is 90.4, and it, along with that angle I just started, forms a straight line, so that would make 180 degrees. So we're going to do 180 minus 90.4, and when we do that, we get an answer of 89.6. So that angle I just starred is 89.6 degrees. And that is the exact same as the other angle over there that was given, angle M. So if the two base angles are congruent, then we can go back up here. We know the angles are congruent, so we can use the converse of isosceles triangle theorem to say that those legs are congruent. So we can say LK is congruent to LM because of the converse of isosceles triangle theorem. So that is why the distances are the same. All right, so for example 2 here, we're given a triangle with some measurements, and it says find each angle measure. So we have to find the measure of angle C here, so this angle right here. Now, the two legs are congruent, so this is an isosceles triangle. We know that top angle there, A, is 38. So we are going to do 180 minus 38, which gives us 142. And then in an isosceles triangle, we know those two base angles are the same. So we know if we added them together, we would get that 142. So in order to solve for x, we have to divide by 2. So half of 142 would be 71. So the measure of angle C would be 71 as well. So 71 degrees is our answer. For the next one here, we have to find the measure of angle S. So again, we're shown that the two legs there are congruent. So we know those two base angles are equal to each other. So I know that x plus 30 is the same thing as 2x. And I'm going to solve for x. So I'm going to subtract x from both sides. So 30 left here, and 2x minus 1x is just x. So x is 30. We weren't asked what x was, though we were asked what the measure of angle S is. So we have to do 2 times that 30, which is 60. So the measure of angle S is 60 degrees. We have two corollaries to look at. The first one is an equilateral triangle, and it says if a triangle is equilateral, then it is equiangular as well. So if we know we have an equilateral triangle, that the sides are all the same, then we know that the angles are also the same. And the other one says that if we have an equiangular triangle, then it is also equilateral. So if we know all three angles are the same, then we know all three sides are the same. So just backwards. So for example 3 here, we have to find each value. So they're asking us to find the value of x. So it's given in our picture here that the three sides are equal, which means the angles are all equal to 60 degrees because they have to equal 180, and 180 divided by 3 would be 60. So I know that this 3x plus 15 has to be 60. So we're going to solve for x here. So we're going to subtract 15 from both sides. So 3x would equal 45. And then we have to divide by 3. And 45 divided by 3 would be 15. So the question was, what does x equal? X is equal to 15. And then for part B, they're asking us what is the value of t. And looking at the figure, we're given that all three angles are the same. So that means all three sides are the same. So that means these two side lengths are equal to each other. So I'm going to move the smallest t. So I'm going to subtract 2 t's from both sides. Then we're going to add 8 to both sides. And then we're going to divide by 2. So t is equal to 4.5.